Welcome to AFA's weekly webinar. My name is Billy Zidek, Manager of Special Projects for AFA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to AFA's webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through the end of 2021 and are open for registration. Professional continuing education and AIA-CLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @afa.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box, and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. If you're just calling in, make sure you send me an email at billie@afa.org so I can send you a certificate if you requested one. The system only recognizes you if you log in. Before we dive in today, let's get to know our speakers a little bit. Kimberly Kilroy is a project manager, and Jeffrey Zisk is a project engineer in Gale Associates Building Enclosure Design and Consulting Group. They both specialize in performing evaluations of existing building enclosures, roofs, walls, windows, doors, and below-grade waterproofing, designing renovations, preparing project documents for bids and construction, and providing construction administration services for public and private clients. At this time, it's my pleasure to turn this over to Kim and Jeff for the presentation. I will rejoin you for the Q&A session later on. Jeff, Kim, take it away.
Thanks, Billie, and thank you all for joining us today. As mentioned, I'm Kimberly Kilroy, one of our project managers in the Building Enclosure Design and Consulting Group at Gale, and here with me today is Jeff Ziske. We'll be presenting the building blocks of enclosure evaluation, just to give you a sense of our process when we get to a site to evaluate a building, look at defects, and recommend repairs.
Thanks, Kim. I'm Jeff Ziske. Thank you, everybody, for joining us today. So we're here to talk about the building blocks of enclosure evaluation. So to give you a little background and a little bit of the path of how we're going to go through this presentation, we're going to start talking about review of existing information. Then we're going to get into some field inspection and visual evaluation, and also some access methods to do that work, and then talk about some testing options, and then get into some report and design documents. So what is this presentation based off of? This presentation is based off of industry standards. A couple of ASTMs are up there on the screen. These are industry design standards or evaluation standards to look at different components of the building. Here at Gale, we actually have previous and current staff members that have helped write and update these standards. So we want to utilize these standards when we're evaluating the building.
So without further ado, we'll jump right into our first step, collect and review existing information. Given today's technology, a lot of this can be done online or remotely speaking with the owner of your building. I like to start with historic photographs personally. You can see a current day photo on the left and a 1939 photo on the right here of the 142 Berkeley Street building. Having both of these side by side allows you to look at changes to the building over time. You can see in front of the crossfit on the photo on the left, we've added a little enclosure area. You can also see, looking at the top of both photos, that during previous repairs, we have a less ornamental cornice at the very, very top of your building stone. If you're looking for historic photos, you have a lot of different options. If you have a nationally registered building, there'll be a report for it available. Otherwise, local libraries, local historic societies, and really even just a thorough Google search can get you a lot of information. Another option would be any previous reports, studies, or evaluations that the owner may have. And these are just a great resource of what's going on with the building, what may be a recurring issue, etc. Similarly, if there's any original drawings available, either from the original construction or from previous renovations, it's a good option to give you a sense of what you'll be expecting when you get on site. And project specifications will give you some more performance-related details. And if you have original submittals for construction, this will give you material-specific information for the particular membrane that was selected, not just the group of them that might meet the performance requirements or whatever your materials may be. On that note, if there's any shop drawings or as-built drawings available from when the building was in construction, this is really going to give you the closest to your current conditions. So I'm sure you've all seen construction projects change as they move along, either due to owner requested changes or unforeseen conditions. So having these as-built drawings will let you know if maybe windows moved around, if we added or reduced the scope, if there were some material changes, etc. If you don't have any existing information specific to your building, just knowing the approximate time the building was built can also provide you with some general information. You can look at building codes from that time or industry standards, either the Brick Industry Association, FM Global, or other groups that will provide you kind of typical expectations at the time, typical construction materials and procedures, in addition to those code requirements from the period. Once you've done all of your research, you'll move on to your field evaluation. And this is really when you get out into the field on site and you can get eyes on what you're looking at. I like to start mine off with the leak audit. It lets me walk the entire interior of the site, and most importantly, it lets me talk to the owner and to facilities personnel who are living and working in this building day to day and are going to be much more familiar with it than I am. While we're doing our walkthrough of the building, we like to document any active or previous moisture infiltration, as well as any airflow or thermal losses that the owner or facilities director might be aware of. This is also a great time to talk about previous repair histories or services that have been done to the building. On this, you'll see just a typical leak audit sheet for an example as we went room through room, identifying the staining, where it was, and discussing with the owner any previous concerns. Maybe it only leaks during storms where the wind blows in a certain direction. Maybe it leaks all the time. It really is going to depend on where you are and the actual specific building you're looking at. A fun side note here, we actually were in Arizona looking at a building where, come to find out, the roof had been leaking for years, and facilities just changed out the tiles every time it rained because it didn't rain that often. It seemed easier than managing the problem. They just addressed that symptom, and so walking through the building, we wouldn't have known if we hadn't had that inside information from them. One of the big things to focus on when you are doing that leak audit is keeping in mind not every leak is going to be part of your building enclosure. We've seen plumbing leaks, we've seen HVAC system leaks, and one was actually on a roof, but not the roof system. We had a new roof system installed and some existing rooftop equipment, and we couldn't find the source of the moisture intrusion. Went up on the roof, all of the flashings appeared to be in order, the new roof system appeared tight, no punctures, no issues or concerns. Upon opening up that unit, it was filled with standing water that was working its way into the building and presenting as a potential roof leak. Also, while we're doing our leak audit, we want to note other items in the building. Maybe there's condensation on windows or walls. Maybe there's vegetative growth or efflorescent staining on a wall. If salt precipitates inside of a window. All of these are just providing you more information about the conditions you have.
So Kim kind of talked about the first step we like to do on site. This might be the first trip to the site to do the leak audit and kind of interview the personnel. Now I'm going to kind of get into when we're actually doing our heavy evaluation and field work. So now we're going to talk about coordinating the field work, and that includes defining the scope of the evaluation. Are we looking at one specific elevation, or are we going to look at the whole building or the whole facility? We want to identify the work areas. Are we looking at the elevations or the roof and different areas like that? And then organize the information that we have so we have it accessible in the field. And then also maybe selecting some test methods that we anticipate using while we're out in the field. And then performing the evaluation. So that includes the field measure up, documenting the existing conditions, also the in-field testing, doing that stuff, and coordinating sampling, which we'll get into the testing and sampling a little bit more in depth further in the presentation. So the visual evaluation, this is when we get eyes on the building to see what the issues are with the enclosure. We're not going to be able to see into the building sometimes, but at least we see what's going on the outside, and we have some other items that will help us to see into the building, which we'll go over, which is test cuts and cores and things like that later on. So, but this is a great opportunity to get out there. We have some background information, hopefully, before we get to the site, so we kind of understand what the construction is, and then we get out there and we see what the defects are. So how do we access the building for our field evaluation? So there's different methods. First method is grade level evaluation with high-powered binoculars. Relatively easy to get out there. We just need engineer or field tech with the binoculars and an iPad or plans to be able to document what they're seeing. There is some limitations to this. If you have a taller building, it's going to be very hard to see the upper floors. Also in congested areas like Boston, let's say, you have buildings so close together that you don't have the right angle to get up there and see it. It's really good as an initial step because we can get out there and really see what's going on and get an idea on the quantity of the defects on the building. But it also helps us to kind of identify areas where we may want to get close-up review of later on with other methods. So other methods to access the building would be swing staging. So this is great for elevations. There's a lot more setup involved in this. As you can see there, we have a big rig on the side of the building here, and there's ballast and attachment that needs to be set up ahead of time, safety lines and everything like that. So we don't usually see this as much for evaluation. Sometimes we'll see this more when we do evaluation right into design, or when the contractor gets out there, he sets this up and it allows us to kind of ride with the contractor to pinpoint exactly what's going on. So, but definitely a great option to get on the side of the building. A little bit more cost and setup to do with this. You also sometimes have to do structural engineering up on the roof deck to make sure that the ballast is placed in the proper location so we don't affect the structure of the building. So another option is aerial lifts and crane access. So this is where we actually get up there in the lifts and take a look at different parts of the building. So this is great because it allows us to kind of conform to different maybe odd shaped buildings and get to certain areas where you really wouldn't be able to get to with a swing staging, or just not be able to see very good from the binocular survey. So there is some permits that are required. Usually you have to do some street closures or maybe even sidewalk closures to get the lifts in there. So that takes a little bit of time. There's some costs associated with this. You also have the rental of the equipment. So a little more cost, but it is useful, and we use this all the time. So a couple of notes on the pictures. The center one is actually a large lift that we used on the air traffic control tower. They had a panel issue up there, and we were tasked with looking at the belly of the structure there and all those panels to make sure that there was not any other loose ones. So I'm actually up in that lift right there. Pretty nice view from up there, a couple hundred feet up. So, and then on the bottom right is a crane access. So part of the same project, we actually had a structural engineer up in that bucket on the crane looking at the structural connections on the side of the tower. So he said it was pretty nice up there, but a little bit of swinging around. So another option is rope access. So you can see that guy hanging off the side of the building there. So this is where we actually set up ropes and actually rappel down the side of the building. So a lot more training involved in this, safety training and just making sure you're certified to do this. There is some limitations. You're not going to be able to see every single part of the building. You have to have tie-off points and everything like that. Other ways that we've utilized this or seen it done in the past where maybe you don't have anyone who's certified is you can utilize other entities who are certified, and you have like an engineer or technician on the ground with an iPad and GoPro, and you can actually see what the person is seeing who's rappelling down the side of the building. So this is a great option to actually see what's going on the side of the building. We do this sometimes with facade inspections. You need to do a certain amount of drops on certain buildings, so it's pretty useful for that. So one access method that's been gaining popularity, especially lately, is unmanned aerial vehicles, otherwise known as drones. Great opportunity to quickly get up and see taller elevations and roofs and other places which are hard to access. So they're pretty easy to get up there. You do have some limitations. You have to have FAA certified pilots, and you also have to, there's certain restrictions in areas like near airports and other restricted areas where you have to get special permits to do it. But when you can do it, it's really easy. You can take off from roofs or adjacent buildings or even the ground and get up there quickly and be able to get a bird's eye view of areas of the building which kind of hard to get to unless you have a lift or crane or other access method, which you may have to shut down street. So this is a project that we did in Boston, and we actually started this one with an initial ground survey with binoculars. We noticed some deterioration around the corners and detail on the top, but we didn't notice we weren't able to see the extent of it until we got the drone out there. You can also see that a couple of these other photos show shelves that you really can't see when you're looking from the ground. So we wouldn't be able to see if there was any cracking or deterioration in that stone. So the drone was instrumental in this project to actually understand what was going on and do a better evaluation. So quick video here. This is an evaluation we did for a building and roof with the drone. As you can see, it's very quick from takeoff to get up there and be able to see stuff from heights. One thing drones are very good at is looking at steep slope roof. So as you can tell, this roof, that would be very hard to access pretty much any other method. So we can take high def photos of what the roof looks like. We can stitch them together. We can defect off of them. So definitely plenty of options with the drone. We at Gale have in-house certified pilots, so we can get right out there with an engineer and a pilot and take care of the drone survey. So the other thing that's great is aerial photos. If we don't have plans on the building, we need something to mark our defects and deterioration and field notes on. So we could go out there quickly for a quick survey and take a couple of aerial photos. Gives us something to use for the field work. So now we kind of talked about some of the different access methods. Now we'll get into a little bit of defect identification and documentation. So when we're out in the field, we utilize checklists, and these help us to thoroughly go through each of the building systems that we're looking at. This one here happens to be a window and door component checklist. So we utilize these as we're going through the field work to make sure we're hitting all the points while we're on site so we can do a thorough evaluation. So just a couple of things we highlighted in this was test cuts. We'll talk about that a little further, but that helps us to understand what's going on actually inside the building, inside the roof or walls. And then we have information from client as available. So this is what Kim talked about before. As-built plans, original drawings, submittals, everything like that are really important to us because we can understand the building. It kind of helps us be a couple of steps ahead when we have that information ahead of time getting out there. When we show up to a building and we don't have any information prior to showing up on site, we're kind of starting at square one, and we have to, it takes us a little while just to get familiar with the building, how it's constructed, and then get into, okay, what's going on with it, how do we figure out a way to fix things. Another opportunity, another thing that we use is checklists and also quantity sheets. So this is a door type checklist. So this helps us to very quickly go through if we're doing an evaluation of doors or a door replacement project. We can identify standard types and quantities of doors very quickly.
So now that Jeff has told us how we're getting eyes on our building and also how we're documenting our defects, I'd like to talk a little bit about what those defects might be for your various building systems. We'll start with the roof and work our way down. So if you have a roof system on your building, it could either be steep sloped or low sloped. Looking at these steep sloped roofing options first, you could have asphalt shingles, you could have slate shingles, potentially metal roofing, either low or steep sloped, and tile roofing. You'll see in your top left photo there an asphalt shingle roof, which has experienced granular loss and what's called shingle bake. Often this will be the result of inadequate interior ventilation to allow those shingles to heat beyond what they were expecting in a temperature range and just accelerate deterioration of your system. In your top right, you can see an overall of that same roof, which is kind of your worst case scenario for shingles. At this point, they've actually had to go in and apply large area patches over the roof just to kind of put a Band-Aid on the problem until they were able to perform a widespread replacement. Some slate shingle defects you might encounter would be cracking, displacement, breaking off of a full section of your shingle, or what's called shedding. Shingle shedding is usually something that occurs in the first year or two after your roof has been installed. And this is actually individual shingles falling out of that roof system, either to a gutter or to grade level below. Metal roofing is susceptible to corrosion, oil canning, or displacement. Your bottom right photo, you can see some deteriorating and rusting metal roofing widespread across the roof system. In that middle bottom photo, you'll see here the rusting is really localized to those fastener locations. And something like this might suggest it's not really deterioration over time, but potentially a material compatibility issue between your fastener and that main metal section. If you have a low slope roof system, you could have a single ply membrane roof. And those would be a PVC, EPDM, or TPO roof systems. These are particularly susceptible to puncture. You can see in that top right photo, that corner flashing, it appears something's gotten caught on it and ripped that membrane open. You can also have unadhered or open seams or flashings, the bottom right photo. You'll see we have sealant terminating the lower flashing, and that upper flashing section is unadhered and open to wind-driven rain. Obstructive drainage can be a concern on any roof, as you'll see in that top left photo, as well as corrosion of fasteners. Once again, you'll see in the bottom left there under your membrane. You could see vegetative growth in the top left photo or bottom right photo. You can have excessive patches, like you'll see in the top right photo, or you can have buckled insulation in the bottom left photo there. The top right, you see all of those small individual patches, and that just leaves you susceptible to those becoming unadhered or opening up over time. We would recommend and prefer to see one larger patch covering that full area of defects. And the good story on that bottom right photo, you'll see vegetative growth is really overtaking your roof drain there. Our field team was actually doing a roof measure up, documenting all of our drain locations and capacities. Got to this section, they're like, listen, I feel like there should be a roof drain here. We don't have one. And in peeling back that vegetative growth, we saw it had just been completely covered.
That also indicates maybe the maintenance on that roof hadn't been done over time, so cleaning roof drains and everything yearly is definitely an important factor there.
Another option for low slope roofing might have a multi-ply roof system. This could be a built-up roof or a modified bitumen roof. And these have the potential to experience fish mouths or wrinkles, granular loss. If you have a coating on top, you could have alligatoring, which you'll see in that top middle photo, or just widespread coating failure over time. There's the potential for mold runs in the bottom left, blisters in the bottom middle, and again, obstructed drainage is going to be a concern on essentially any roof system you have. We really want to be doing that regular maintenance and making sure that we're keeping those clear to allow stormwater to flow. Puncture is also included here as a potential concern. It's less likely because you do have the redundancy of those multiple plies, but there is still a chance of it. Some other low slope roof options would be an IRMA, inverted roof membrane assembly, or a vegetative growth. Vegetative roofs can be intensive or extensive depending on the amount of soil and the level of vegetation you're looking for. You see small sedums in the photo on the top here. You could have the potential to include full-size trees with the appropriate design and drainage. Some potential concerns would be obstructed drainage, once again, especially with these roofs where you do have all of that growing media. Membrane puncture, again, with all that growing media above it, you really want to make sure that your membrane is good to go before we put that on. You don't want to be pulling out plants and soil and trying to find that one leak that maybe doesn't even line up with where moisture is coming in. The biggest concern really would be overloading that roof system, especially if you're retrofitting, your existing framing wasn't expecting that weight of the soil and weight of the vegetation. And if you're not doing it right and getting structural engineers involved, there's the potential that you could overload the system and have the bottom photo there, which is just a widespread collapse of that building due to the overburden pressure. Quick disclaimer, that bottom one is not a Gale project. We just wanted to put that in there as a friendly warning. If you do consider this green option as people look to use rooftops as green space and to really make the most of their building footprint. Working our way down the building, when we finish our roofs, we'll start to look at our wall systems. Some masonry options would be brick masonry, CMU, or stone masonry. And these can be susceptible to cracks, spalls, impact damage, unsealed penetrations, staining, or even efflorescent staining in particular. I've shown you kind of a few sample defects for you here. In the top left, you can see a crack. Top middle, you have a spall. Bottom left, you have that unsealed penetration, or partially sealed in this case. And then the bottom middle, you have some staining below your windowsill. In the bottom right, you'll see that white efflorescent staining. On that top right photo, I want to talk a little bit more detail. You can see the impact damage to your brick masonry here. A large section of it's broken up and deteriorating now. The big thing to look at is not always just the source the symptoms that you have, but also the source of what you're looking at. So this photo in particular was a loading dock. Because the pads at the bottom of the loading dock were undersized, instead of hitting the pads, trucks would back down that hill and slam into the brick above. So something like this, if we had gone out and just looked at the damaged brick, removed them, replaced them, and we were on our way, the next time a truck backs into that loading dock, we're going to redo that damage. With that in mind, you always want to look past your symptoms and try and find the source. Similarly, step cracking in masonry, widespread deteriorated mortar, rust jacking, or masonry displacement. For example, that bottom left photo, you can see the corner step crack there coming off of your window opening. Most likely, this is the result of rust jacking, and that's going to be your steel lentil beginning to deteriorate. As steel deteriorates, it expands to up to 10 times the size it started. It's going to put a lot of pressure on that brick masonry that it wasn't expecting, resulting in the crack. So again, if we just rebuild that crack and we're not addressing the main cause of the issue, we're going to see those repairs be done time and time again. Your bottom right photo is really just your worst case scenario. If you don't keep up with that building maintenance, you're not repointing those brick joints, eventually you'll get to a point where the deterioration and moisture infiltration is so severe, full sections of your brick wall are starting to fall off.
So to continue on the wall theme, we're going to think about some concrete wall defects that you may see. This could be cast in place or precast concrete elements. So those include cracks, spalls, and exposed reinforcement. Those are the kind of the typical ones that you would see. So top left photo, you can see a spall there. That was actually at the bottom of a wall section. There was some debris and wood in the bottom of potentially the formwork, which caused that spall to accelerate and pop off. You also have cracking on the left, which that is, I mean, it's just cracking, but because it's in an area, that cracking could result in a big spall coming off, which could really result in exposed reinforcement. And then the middle photo there on the bottom, that is exposed reinforcement. And the issue with that is left untreated, that corrosion will actually extend further on the reinforcement, and it could start popping off adjacent sections there. Exposed reinforcement, there's a couple different reasons that it's caused. There's a potential that there was not a proper clear cover of concrete over the top of the reinforcement from original construction, so moisture was able to work its way in and corrode that steel. There's also, if you're near the ocean or something like that, you could have salts and other things that are getting into the concrete if it's very porous to corrode the reinforcement. So similar with concrete structures, you also have concrete parking garages and slabs. So they're going to have very similar defects, cracking, spalls, exposed reinforcement. Parking garages typically have a lot more sealant joints at expansion joints and different panel systems. And you could also have the failed coatings, which could allow for moisture to get into the concrete below. So windows, there's failed sealants. That could be perimeter sealants or actually glazing sealants. You have damaged screens, damaged gaskets. As you can see from the top right two photos, you have a perimeter sealant and damaged gasket on the right. You could also have failed glazing seals around insulated glazing units or broken glazing. You have air moisture intrusion issues, and then also just deterioration of the frame. So looking at the top left photo, you have a screen. It's actually just an insect screen, but it's deteriorated. You could have security screens on lower levels. And then the bottom right two photos is actually deterioration in the frame. So the middle photo is an aluminum frame that's actually been deteriorating along the masonry joint there. And then the bottom right photo is a wood window, which has heavy weather checking. So wood windows have their own set of problems. So doors, you could have failed sealants, failed weather strippings. That's very common. As you can see from the top left photo, it's half missing. You could have displacement of the door or frame, and then or deterioration of the door and impact damage. Impact damage is very common around loading docks or other maintenance access points. So when we're thinking about doors, we also want to consider rooftop access doors. So when we do a roof evaluation, we want to kind of look at any roof access doors and how a roof system or roof system replacement will impact that door. Last thing we want to do is go and design a full roof replacement, and the access door had a problem and was leaking, and it presents itself like a roof leak, which is right adjacent to it. So we kind of consider that part of our roof assessment when we're looking at that.
So in addition to looking at each of these individual building components, we also really want to take the appropriate amount of time and attention to focus on the transitions between the systems. With this, the devil really is in the details. It's a very small percentage of your building where these systems transition between each other, but it's often a lot of your building's issues and concerns. The reason being that each product manufacturer and each trade is really focused on their work area. They're not necessarily thinking, when I finish building this wall, how am I tying it to the roof? How am I flashing my window into the surrounding wall? And so we like to consider those roof to roof, roof to wall, roof to window, and roof edge transitions. On that top left photo here, you'll see that your roof parapet cap has been flashed to the brick masonry rising wall with an adhered membrane section. The issue here is the brick masonry is meant to take on water, but it weeps back out. So now that we've trapped that water from the brick wall, it really has nowhere to go except either into your parapet or down into your roof, or maybe even into the interior of your building. Similarly, in that top right photo, you'll see the roof system has been flashed right up against the frame of your window. This is a big concern because windows are not a waterproof system. Windows are a water management system. They're going to take on some amount of water, which is why manufacturers have weeps at the bottom of those windows. Unfortunately, because of the way we flash the roof, we're now weeping into that roof system, and again, potentially into the interior. On the bottom photo there, you can see our roof edge transition, where your sheet metal fascia is not actually coming all the way down over the deck flutes, and that end is exposed. This could be an air infiltration, a moisture infiltration concern. In this case, it's a canopy roof, so we're not extremely worried about those. However, you also see in the photo, we've built a lovely bird condo community here, and as they're flying in and out of those flutes, we're going to build up guano that's going to accelerate deterioration of that roof deck and potentially require replacement sooner than we otherwise would have needed.
So one note on this slide, this is actually a project that Kim and I worked on together. We did a full facade evaluation on this and did a little bit of look at some of the roofs. These are all from one project. So this project in particular, this building had quite a bit of transition issues. So the transitions were definitely not thought about a lot when this building was built.
And we're going to refocus again on that roof to wall transition because this is the one that we see the most. Here you have your roof membrane coming up, and we have an exposed termination bar mounting that roof system to the surface of your brick wall above. Again, your brick wall is going to take on water, and we've given it nowhere to weep back out now except into our roof system below. Instead of this configuration, we would recommend a through-wall flashing. It's not just a through-wall flashing, though. It's about having the right through-wall flashing. We want to make sure that we're extending that beyond our roof edge. We recommend a good 8 inches past the edge of your roof because water is going to travel through your brick masonry, not necessarily perfectly vertically. So as that can move across the wall, if we extend 8 inches beyond, we can capture that moisture, weep it back out of the wall above our roof flashing, keeping it out of our roof system. We would also recommend end dams, which you can see there, especially in the zoomed in photo to the right. That's where that vertical leg of the flashing coming up and preventing lateral movement of water.
So now we've gone through a lot, just a sample of some defects you would see with these type of wall systems and roof systems. There's all kinds of different defects and conditions that you can see. This was just kind of a sample. So now we're going to talk about some of the performance criteria that we're getting into. We're thinking about this when we're evaluating the building and putting together our reports and everything like that. So for roofs, we want to think about the structural capacity of the roof deck and the roof framing. That may be related to snow loading or drifting snow. Sometimes older buildings, owners will have us look at the drifting snow conditions at rising walls and stuff and actually design reinforcements as part of a roof replacement. But we want to make sure that the structure can handle the new roof system that we're proposing or what's on there now. Then you have thermal issues, so we want to make sure that we're bringing it up to the current R value for the roof replacement, having multiple layers of insulation staggered. We want to think about the drainage concerns. That could be internal roof drains or gutters or scuppers. Also, secondary drainage is required in quite a few states, so we want to make sure that we have proper secondary drainage if those primaries get clogged so that the roof does not overload with excess water. You also have vapor drive. So that's where we want to consider vapor retarders and make sure that they're in the right place in our roof system. So for windows, you have a structural concern. This is the attachment of the window to the structure itself. You may have punched window openings or clerestory windows or curtain walls. You also have thermal. We want to make sure that we have proper insulated glazing units and also thermally broken frames as much as practical so that we can get the required U values for those window openings. And that also we want to think about the infiltration concern. So we want to make sure those weeps are open. Like Kim mentioned earlier, the weeps below the roof, that's not a good thing. So we want to make sure the weeps are open, and also we want to make sure that the openings are properly flashed so that any moisture that gets in above the lintels or around the window frame gets out of the wall and doesn't continue to go into the building. So walls, there's many different types of wall system. We want to think about structural concerns. For the masonry walls we have shown here, you could have a masonry veneer that's tied back with lateral ties, or you could have a mass masonry with headers holding that outside white in. You also have drainage concerns. We want to make sure, like Kim was talking about, the through-off flashing is properly installed, or at the base of the wall, between floors sometimes, and then also above any stone elements. Thermal concerns, a lot of mass masonry walls, you don't have insulation in the wall, but cavity walls you do. So we want to make sure that we're insulating walls properly and not changing the dew point and messing with the wall construction itself. And then infiltration. Your walls, most wall systems are meant to take on water, like we talked about previously, and we just want to make sure that we don't have large openings that are open that allow bulk water in. So a lot of times what we see when we're evaluating buildings is conduits or different penetrations have been put in by a trade contractor, and then it's not sealed up. So those are a lot of the areas where you're getting a lot of bulk water in. If you get too much water in the wall system, the wall is not meant to handle that and will work its way into the building.
So that'll bring us to testing. Again, we've already done our research. We've gone out on site. We've looked at the building. We've walked through it. We've spoken to facilities. We've defected our elevations. Now we're going to hone in on those areas that we want to do some testing to get a better understanding of what's going on. The point of this testing is kind of threefold. We want to verify our hypothesis. We want to recreate and trace the path of those leaks that were documented during our leak audit. We want to correlate the testing with the observed damages and those defects that we saw. The last thing you want to do is look at the outside, mark up your defects, go to the owner, get them fixed with the contractor, and then still have a building leak. So we want to make sure that what we're seeing is lining up with the interior symptoms so that we can address the appropriate sources. Types of testing available too would be non-destructive, destructive, and laboratory testing. We're going to walk you through a couple of sample options today. This is by no means an all-inclusive list. It's just to give you an idea of the type of testing that we may use individually or in conjunction with each other while we're evaluating a building. So jumping into non-destructive testing first. We do a lot of infrared thermography or IR surveys or scans. And what this does is it picks up a temperature difference in your materials. It can allow you to identify potential moisture in a system, air leakage, or thermal bridges. In that photo to the left, you can see one section of your roof is much brighter, much warmer than the surrounding materials, which may potentially be moisture in your roof system and in those materials. Photo on the right, you can see those vertical blue lines, which are actually studs. And you have the green in between them, which is mere cavity filled with insulation. One of the big things we like to keep in mind with the IR surveys is that not every anomaly is an issue. You also see a very white, hot blob in that bottom left of your right photo, and it's actually a lampshade when you take a closer look. So again, this is locating anomalies that could point to moisture, air leakage, or thermal bridging, but we would want to do some follow-up. We would want to be analyzing these appropriately. Another option available too is electric field vector mapping. This is a great option in particular for vegetative roofs. As we talked about, if you have a small puncture in that roof, the last thing you want to do is dig up all of those plants you just put in and all of that soil. Even if you have trays, it's a huge amount of labor picking up each tray, removing it from interlocking with the adjacent ones, moving it somewhere else, and trying to locate that leak. So if we can plan ahead, if we have a concrete deck and include some sort of conductive media, or if we have a metal deck, it's a great option to identify those leaks via a grid rather than removing all of your soil. Some other options to identify potential moisture in a roof system would be a nuclear moisture analysis or a capacitance moisture survey. If you have opened up your materials, be it a roof system or a wall, you have a moisture meter available to you that can give you the percentage of moisture in that particular material. We also see a lot of Ryland tube testing when we're working on evaluations, and this is really used to get the porosity of your materials. Whether it's your brick, your mortar, or your stone, How quickly water is absorbed and how much water is absorbed will give you an understanding of the porosity. This in particular is useful on older buildings where we're trying to do repairs in kind with the original construction and have something compatible with those existing materials to repaint.
So air leakage testing can be done as a test to figure out what's going on with where the air is coming into your building or escaping your building. So air leakage testing alone is tough to see exactly what's going on, but it's usually used in conjunction with another test. On the left here, we have a couple of photos showing it with an IR scan, and then on the right bottom photo, that's with a smoke test too. So that helps us to trace the actual locations where the air is leaking from. So there's a bunch of different ASTM standards. Air leakage tests are typically kind of a blower door test, are known for that. So on the left, we have a couple of photos with a test that we did, and we had air leaking around light outlets. And then at the bottom left, we have air leakage at the base of the wall from the foundation. So that was not properly sealed. And similar photo on the right with the smoke test, you have an air leakage at the base of the wall, and that same joint is not properly sealed. So crack gauge monitoring is another option for observing the crack and how it's moving over time, especially with concrete or masonry. This can help determine if you have issues with settlement. Is it short-term settlement or long-term settlement, or is it something that's continuously moving? So this will help us to determine if the crack, if we just repair the crack in place, is it going to crack again, or is there something else going on with the building that needs further review? So this is not a quick test. Usually this is something that gets installed and then monitored over time to see what that movement is. Concrete sounding can be done with a hammer. This can also be done on brick. You're looking for hollow sounding areas, which indicates that there's a void in the concrete or an air pocket. Typically is delaminated concrete area, so sounding can be done to do that. So similar with sounding is chain drag. This is just another method to do a larger area of sounding. This is used primarily on parking garage structures or roof decks to find the deteriorated areas that may be kind of hidden under the surface.
So as Jeff mentioned, that chain drag is a great option if you do have a large area that you're looking at. And after you've kind of honed in on where those anomalies are, areas that might be of concern or of interest to you, we would kind of look to other technologies available. You could use ground penetrating radar or a concrete scanner. And this can help you get your slab thickness, your reinforcing steel, spacing, and depth, identify any other anomalies in the slab, either pieces of wood or something else that may be in there. I actually found one slab with most of an extension cord in it. While they were replacing the concrete, the extension cord was dragged across the slab. Clearly, as it started to set up, no one realized this, and by the time they did, they decided to just cut both ends of the cord and leave it in the slab. Another option too, not really a test method per se, but a great tool in your toolbox, is hydrothermal modeling. You often hear this referred to as WFI, as that's one of the softwares available. And this is really just a computer-based means of identifying where your dew point is going to be in your wall. You would input each of your materials, its thickness, you would put all of the material densities, your temperatures, your relative humidities, and once you've identified that dew point, by running the program, it allows you to place that vapor retarder Jeff had talked about in the appropriate place in your system. Moving on from non-destructive testing, we'll go through a couple of options for destructive testing. Before that, we're going to talk about the kind of in-between test. I consider water infiltration testing to be destructive because we are applying water to your building. We're trying to create a leak, so there's a chance that water is going to get inside and damage something on the interior. That said, water infiltration testing can be preventative or it can be for troubleshooting. During new construction, a lot of window projects will use AMA standards for testing, and they'll test the mock-up and a percentage of the windows to confirm that we're not allowing moisture into that new system. You can also use it for isolated testing with ASTM standards of building walls or other components. And really, if you're doing it as a troubleshooting method, you're trying to recreate that leak and find the path that water is working its way into the system. Moving on to true destructive testing, you can take test cores where you're, as it sounds, actually coring out a section of your material that you then have as a sample. This will allow you to figure out the depth of your material, how its consistency may or may not change across that depth, and also provide you with samples for future laboratory testing. Hand in hand with test cores would be test cuts. Destructive test cuts are a great option when you can do them because they allow you to get your hands and your eyes on the actual in-place conditions. You're physically opening up that roof system or that wall and seeing exactly how it's configured. The photos you have here, you can see your roof system on the bottom left, and in opening that up, we now know how much insulation is in the existing roof. We know whether that area was wet or dry. We can identify potential deck coatings or other things that might impact our design. In the bottom middle there, you can see a chimney test cut with your outer and inner webs of masonry, as well as a little bit of your terracotta flue there in the middle of the photo. On the right, you can see a window test cut showing your window frame and the wood around it where it abuts your brick masonry. And again, test cuts are not going to be done throughout the entire building. You would pick those small areas that you want to focus on, and those would provide you with an understanding of your existing conditions. While you're doing those test cuts, it's the perfect time to take your samples for hazardous material testing. We would strongly recommend employing a hazardous material consultant for this. The sampling and testing licensing requirements really do vary by location, and they change over time. So you want someone who's really focused on that and able to test for you for lead, asbestos, or PCBs. We really want to try and get this done during the evaluation stage so you know what you're getting into. If you proceed with the evaluation without hazardous material sampling and testing, you might uncover something during construction, and at that point in the game, it's going to add a lot more cost and may delay your schedule. Some laboratory testing options would be gravimetric analysis, petrographic analysis, various absorptions, compressive strength, density testing. Really, there's almost an endless list of test options here. We just presented a couple to give you an idea of what you might be looking at.
So we just went through a whole bunch of background information. We did a lot of field evaluation methods, access methods, defect identification, typical defects, testing, all kinds of stuff. So how does this all kind of get wrapped up? So we're going to put together a report, and this report will be something that the owner can have that tells them the condition of their building, but also something that they can pass along for future projects, so that we make sure that everybody's aware of what we saw and then how it changes from then on. So what goes into a report? We have the 6 C's. So those include condition, cause, culpability, correction, cost, and calendar. So we want to make sure that we are hitting all of these 6 C's. And what we do is we utilize all of the different methods and items that we previously talked about so that we have comprehensive information that we can put into our report. So one, that's the existing conditions kind of. Now we want to talk about and think about the code requirements. So what do we need for wind pressures for the new roof system, or if we're recommending that, or the windows? We want to avoid what we have on the top right photos with roof failure. So we want to make sure that the wind is it's properly designed for the wind pressures that are needed for current code. You also have thermal insulation, seems to be ever increasing for roofs especially, but we want to make sure that, and the test cuts like Kim talked about help us to determine what's the height of the insulation and then how much insulation do we need to put. It's not easy just putting more insulation. That sometimes can create a domino effect here. You got to raise all kinds of equipment or dunnage or doors and things like that. So that's one thing when during the evaluation we kind of see what's impacted. You have drainage capacity. Again, secondary drainage, we want to avoid the photo on the bottom left. We do not want to see water ponding on the roof because that could cause the photo on the right, which is overloading of the roof deck. So that goes into the gravity. We also have snow loading, drifting snow, vapor drive, fire ratings for different types of roof systems, and then egress and accessibility. So accessibility in Massachusetts, accessibility is required on publicly or state maintained buildings after we hit a certain threshold. So we want to make sure that we're understanding what the impacts are of this project. So if we're getting over a certain percentage of the building, that may actually trigger repairs and other upgrades in the building, not just to put the roof on. So repair recommendations. This is where we want to get our existing condition code requirements and then put together the recommendations for the owner so they can understand what they need to do to fix these issues. So that includes defining the scope of work, system selections, making sure we're meeting the client's needs. Do they want to put solar panels on this roof? Do they want to change the access method? They want to try to avoid what's on the bottom right there with the roof hatch right on the edge. But how does the owner how would they like to deal with this? Put rails up, relocate it, put a ladder up, things like that. Also putting together cost estimates and making sure that everything that we have, if it's a historic building, is compatible and goes through proper reviews so there's no issues during construction. So repair recommendations, we can help with scheduling and also defining that in the report. So is this phased work? Is it a full facility? Do we need to do multiple roofs in different years or all together? And also helping to define that long-term plan. So timeframes usually there's immediate, and this is like fall hazards or active moisture infiltration. We also have short-term, which is like 2 to 4 year repairs, something that's on its way out but can last a couple more years. Intermediate repairs, something to plan for in the short term and the intermediate term, and then long-term repairs for long-term planning, which is the 8+ years. So here's an example of a cost estimate that we put together for a full facility roof replacement job. So as you can see, it's color-coded by the terms. These terms are a little bit different than what I just went over. The owner had their own request for the terms and how they planned their budgeting for their repairs. So as you can see, in the immediate term, we had to replace a couple of roof areas, and then we did repairs to a number of other ones. And that helped extend the service life so that we could plan those out for longer, greater term. As you can see, there's quite a bit of money talked about for roof replacement here for this full facility. So we have to kind of help them spread it out so that it can be budgeted and taken care of. So, and this all gets wrapped up into a report. So we went through a whole bunch of different things here. You're not going to typically use every single thing that we had here on one project. You're going to tailor it to that specific project. We're going to make sure we're using the right test methods, right access methods to get the project done. But this was a nice little overview, and we wrap it all up in a report. So that concludes our section. I'd like to thank you for joining us today. And I think we have some time for some questions.
Yes, and we do have a couple of questions coming in. Our first question is, with testing, sampling, etc., in an older building's analysis, do you recommend that there be unit prices established for some processes, setting an agreed expectation of cost to apply to potentially growing scope?
Right, so really most project, whether it's historic or not, we would recommend carrying those unit prices. As mentioned in the question, you really do want to get that kind of locked in before you start the project. Even a newer building, if it's experiencing masonry deterioration over time and we have those cracked and spalled brick units we're replacing, you're going to have a couple extras that you may or may not identify during construction. If you're using the various access methods available, if you're looking up at a building with binoculars, you might not have the right vantage point to see every single brick on the building. Maybe you have water table stones at floor lengths that protrude, or other things that might interfere with that quantity. So we would recommend having the unit pricing, having that in the budget and your bid price, and just giving the best options for the project to go smoothly.
One more thing to add to that is test cuts. We're looking at like 1% of the building. So we can see what the conditions are there, but we're not able to see everything underneath there. So it's always good to carry unit prices for known things that may be uncovered during construction.
Okay, thank you. On the crack gauge monitoring, what length of time are we talking for leaving the monitor in place?
So that's really going to depend on your building, unfortunately. From a geotechnical standpoint, you have both primary and secondary consolidation. So depending on how new your building is, how severe the crack is, how that crack is changing over time, you're going to need to plan accordingly. There are ASTMs for just different options for applying those and testing, but at some point it's going to be your engineering judgment.
Thank you. Our next question is, what is the best method for testing roof core for moisture?
It really depends on your roof system, to be honest, and what you're trying to ascertain. So we presented a couple of options. IR surveys are pretty easy to do. They're not invasive to your roof system. You're not cutting that open to find out. That said, an IR survey is only going to tell you what is at those top layers of your roofing. If you have, like Jeff said, an R30 roof system, if you have water under that insulation, an IR scan is not going to pick that up. Whereas if you went out and did isolated test cuts, You would identify that moisture when you took out the insulation and there was water below it, but then you're only doing test cuts on a small percentage of your roof, so there's pros and cons to each. It's really going to be project specific.
So with the actual test cuts itself, usually you can see if there's moisture in it. You have staining. If you have polyiso insulation or something like that in your roof system, you can actually see the staining on it, or it could be saturated. We usually in the field can pretty easily tell if roof is compromised when we're doing test cuts. But another way you could do it is you could use the moisture meter and actually test the moisture of the components that you're pulling out to see that if you have moisture in it.
And again, it's just going to be knowing those different test methods. Even, for instance, we had talked about a nuclear moisture analysis, something like that. You're only going to be able to read up to a depth of 10 or 12 inches. So knowing roughly how thick your existing roof system is going to be a factor in choosing the appropriate method.
Okay, thank you. What are the downsides of sealing brick masonry?
We might need a little bit more information on that question. As we talked about, brick masonry is a porous material. So if that is going to take on water, we would want to give the brick a chance for that to weep out either through the face of the units or through a flashing above your roof system, your window, etc.
So there's multiple different types of sealers and coatings that you could put over brick masonry. You really need to do a thorough review of those. Sometimes those sealers can actually trap moisture in the brick and help and deteriorate the brick faster. But there are other breathable sealers and stuff. Sometimes they become maintenance issues. So those are just something that you just need to look at what the condition of the building is, what type of sealer you're trying to do, and what the intent is for adding a sealer to a brick masonry wall.
And like Jeff said, the big thing there is going to be you are creating a maintenance item. Once you've sealed that brick in, you're going to need to maintain that for the duration of the property's life.
Okay, well, thank you. Our next question is, are providers pre-qualified to carry out destructive sampling, and when removing elements, especially masonry, are they following a stamped plan?
So typically when we're doing test cuts, we hire licensed contractors to do that work. So we do that so that they're the ones who are licensed in the state or in that area to actually do the work. So that allows us to lean on their license to do that work. So I think that answers the question.
And again, we would have insurance through that contractor for everyone involved in the process. You wouldn't usually have a stamped drawing per se that you're using. Your engineer would be in the field with the contractor who's doing the cuts pointing to, hey, can we open up this area? We'd like to look at this. Obviously, if we're doing a masonry cut, shoring would need to be considered.
Yeah, we want to make sure that we're not compromising the structure at all. So I guess if you were doing more of a major cut in the slab or something like that, that may take a little more engineering beforehand to understand what's going on. But for typical brick masonry or roof cuts and stuff, it's usually just done by a licensed contractor.
Okay, thank you. What are the minimal credentials or certifications should personnel performing third-party evaluation possess?
So that depends. Our office, usually we have architects, registered engineers. We also have registered roof consultants and things like that. So that's our office. Really, you just need to have an understanding of the building enclosure systems and be able to understand what systems you're looking at, what defects, and what's going on.
And that will vary a little bit from state to state as well, what licensing is required for evaluation or for evaluation through design, whether the company needs to be registered, whether just the individual leading the project needs to be registered, et cetera.
It also depends on the scope of the evaluation. Just an initial evaluation to understand what's going on with your roofs and how old they are, maybe not, but if you're getting a really thorough evaluation to get into design documents, we would recommend a registered professional or somebody who's a building envelope consultant for that.
And also, just as the owner, you want to put your building in the hands of the most qualified person you can.
Okay, we have time for one more question, and I want to let everybody know that the slides will be available tomorrow. You'll get a follow-up email from me with a link in it, so if you're interested in getting a copy of the slides, just let me know. Okay, our last question. What quality assurance measures, inspection, testing, etc., do you recommend during the construction phase for a typical membrane roof replacement to ensure a quality outcome?
So for a membrane roof replacement, there's a couple different quality control, quality assurance things that we would recommend for that. First off would be submittal reviews and everything during the initial part of construction, making sure that all the products and everything are coordinated with the design documents and they match what the intent was. The next thing would be manufacturer's inspections on site during the installation. We want them there doing maybe membrane pull test or observing what the materials are going on, because they're the ones who are potentially giving a warranty for this system. So, and it's their system, they're the experts on their components. So we want that. Following up after the roof's installed would be punch list by the design team, the roof manufacturer, and then potentially you could do an IR scan or one of these other moisture surveys. We have done for larger projects IR scans post installation, because that just makes sure that, because you're usually with a membrane roof, you're doing it in sections. So you're going to have those tie-ins. So you want to make sure that that night tie-in didn't let a little bit of moisture in and then it got roofed over. So those are some items and some options, and those are usually all kind of worked into the design documents and the specifications for that project, but that can help.
But again, there's going to be some flexibility building to building and owner to owner, depending on what you're looking for. As Jeff mentioned in one of his slides, insurance can play a factor here. FM Global, for their new roof system installations on buildings they insure, will require either a full-time third-party monitor or uplift testing at the end of that roof installation to confirm that it's meeting what we designed for, it's meeting that required performance. Gale can also provide full-time monitoring as needed if that's what a client is looking for. Maybe the roof is over a more sensitive part of their facility and they just really want to be fully confident and assured that they're getting what they're expecting day in and day out.
Okay, well, thank you. That's all the time we have for today. So Kimberly and Jeff, thank you so much for your time today to do this presentation for us. And to our attendees, as always, thank you for taking time out of your busy schedule to be with us. So until next time, be safe, stay healthy, and be kind to one another. Thank you so much. Goodbye now.
Thank you.
Thanks.